Hello guys, hope you are all doing well. In this video, I am going to explain this problem of the day from lead code search in rotated sorted array. Let's get started. There is an integer array nums sorted in ascending order with distinct values. This is very important given here, important thing. It is going to have distinct values. It will not have repetition. Its values will not have repetition. Now, prior to being passed to your function, nums is possibly rotated at an unknown pivot index. Will be given an array nums and that too will distinct values, and before giving to us it will be rotated at some unknown pivot index. Now we'll see what is this rotation. Suppose we have this array 2 3 4 8 7. This is not sorted. Here I am just explaining the rotation. If I rotate it, it means that if I rotate it one time, then this 7 will come in the front, and then rest of the elements that are ahead of it will come after it. 2 3 4 8. This is rotation. This is basically rotation. Now how we are performing rotation here in this problem? Here we are performing rotation through an pivot index. Suppose we have an array 4 8 10 15 20, and there are indexes, some index, let me write here their indexes 0 1 2 3 4. So rotation will be there from at an unknown pivot index. Let me consider this pivot index as 2. If I consider this pivot index as 2, then the rotated version of this array is going to be starting from this pivot index, that is pivot index element, that is 10. So I will start from here 10, then after this I will go till end, then 10, after that 15 will come, then 20, and after 20 I will start from the beginning till the element ahead of this pivot element. So I will write 4 and 8. So now this is the rotated version of this array if I perform rotation taking that pivot index as 2. This is only mentioned here. We are going to rotate it at unknown pivot index k, and k will lie from 1 till length minus 1, and such that resulting array will be k plus 1. So in the starting we'll start with the pivot element, that is nums k, then all the elements till end will come. So I have done the same here. I have started with the pivot element that is at index of the pivot index, and all the elements after it till end will come. Here they have all come. Then after that we'll start from starting element of the nums array. So here I have here the 4 has come, then 8. So this is only given here. This is rotation. Now given the array nums, after the possible rotation will given this array, first it was sorted, then it was rotated, and then it will be given to us, and will given another integer target, and we have to return the index of this target. If it is in nums, we have to find out at which index it is present, and if it is not present, then we have to return -1. Simply we have to search it at which index this target element is present, and we have to return that index. Now we can say that here we can perform linear search in big O of n time complexity, and we can easily search this target element and find out its index. But the problem here is not about linear search, it is about log n time complexity. We have to search this element in log n time complexity. So how we are going to do that? See, whenever these two terms, search and sorted array, comes together, it means that there is a possibility of applying binary search. Same case is here. Here we can perform binary search, and we know that time complexity of binary search is log n, and here expected time complexity is also log n. So we can think about binary search here. But how we are going to use binary search? It can be used only with the sorted array, but this is sorted, then after there is only one change, it is rotated after sorting. Now can we, after rotation, can we make use of the sorted property? Yes, we can. Let me take this example, other example to show you. I am taking this example 1 given here. Here elements are 4, 5, 6, 7, 0, 1, 2, and their corresponding indexes are 0, 1, 2, 3, 4, 5, 6. If you observe here carefully, if you pay attention, then you will notice that there are, this array is divided into two parts, and these two parts are sorted in itself. So this part is sorted and this part is also sorted. But if we consider whole array, it is not sorted. Now if we consider arrays as two parts, then there are two sorted parts, and we have to only find out that these two sorted parts. So we'll start with the normal binary search, regular binary search, in which we take one left at the starting index, right left pointer and right pointer at the ending index, and then we find out mid using the formula left plus right divided by 2. Here also we are going to do the same. We will find the mid, and here in this case 6 plus 0 will be 6 upon 2, that is 3. It will come here, this element and this index will come as mid. Now we have to search it, whether we are in a continuous sorted part or we are not in continuous sorted part. Now here we are going to find out that if the left part is continuous sorted part, or if the right part is continuous sorted part. How we are going to do that? So we are going to do that, it is the mid index. We will compare this mid element with the first element, that is starting element at left index. If it is smaller, then we'll surely know that this part is sorted. If this element, starting element, is smaller than this element, then surely this part is sorted. And using the fact that this part is sorted, we can easily search that if our target element is in the range from here to here, if it is between 4 to 7, then we are going to search in this part, or we will eliminate this part. If it is a target is not in the range of the elements from 4 to 7, then it is not going to be here. All the elements smaller than 4 and greater than 7 are not going to be here, and any element that is between 4 to 7 will definitely lie in this part. It will not lie in this part, then we'll discard this part. After finding out the continuous sorted part, we'll search for the range, and we'll find out if the target element is present within the range or not. There can be case that mid is, suppose the element we have to search is in this part, then it will not lie in the range. Suppose we have to search for 0, here target is also given as 0, so we'll find out that is 0 greater than 4, greater than equal to 4, or and at the same time it is less than equal to 7, false. Then we'll simply eliminate this part. This is the basic concept of binary search. We eliminate one part and we move on to the other part. How will we eliminate? We'll do this left is equal to mid plus 1. And suppose if element that we have to search was not 0, if it was let's say 5, then we'll test the same condition if 5 is between 4 and 7. Yes, it is in between 4 and 7, then we'll eliminate this part, and we are going to do perform next search in this part, and we'll eliminate by doing that by changing the right pointer as right is equals to mid minus 1. So this is the main concept of this problem, and using this concept we are going to find the target element using binary search in log and time complexity. Let me code it so that it will become more clear to you. We'll start with declaring the left pointer, left starting from 0 and right starting from the last index, that is nums dot size minus 1. Then as we do in normal binary search, we'll continue the while loop. We continue while loop from till left is smaller than or equals to right, till the left is not larger than right. We'll continue this while loop. Now in this while loop we'll find out mid. Int mid is equals to left plus right divided by 2. Now after finding out mid, we'll see that whether the right part is continuous shorted part or the left part is continuous shorted part, and definitely one of them will be sorted continuous sorted part. We'll check if nums left is smaller than or equals to nums mid, then it is sorted. Then we'll perform some operation, else in else condition we'll perform some other operations. Now we'll see what we are going to do if it is sorted. If the left part is sorted, it is the case when left part is sorted, and this else is the case when if right part is sorted. See, here we have divided the array through this mid index, and if this condition is true, then the division, after the division the left part is formed, it is sorted, and if it is not sorted, then definitely the right part is going to be sorted. Now we'll check inside the sorted part if our target, first of all we'll see previously that if that target is present at mid or not. If nums mid is equals to target or not, then we'll simply return here itself, we'll return its index that is going to be mid. And if it is not the case, then we'll search for the left sorting out of left or right part. Now we'll come in this if condition, and we'll check if target is present in this range from left to mid. So target is greater than equals to nums left, and target is less than equals to nums mid. If it is the case, then definitely our element is present in the left part, and we'll focus our search in the left part by changing the right pointer. We'll do right is equals to mid minus 1. In else condition we know that it is not in the left part, our element, target element, is in the right part. So we'll focus our search in the right part by changing the left pointer by doing this left is equals to mid plus 1. And similarly we'll do here, we'll search for our target element in the right part first. So we'll see target is greater than equals to nums mid, and at the same time our target is less than equals to nums right, then definitely it is in the right part of the sorted array, and we'll focus our search in the right part by doing this left is equals to mid plus 1. Otherwise we'll focus our search in the left part by doing this by changing the right pointer through mid minus 1. If it is present in nums, then definitely this condition is going to hit and will return our index. And if it is not at all present in our nums array, then we'll come out of this while loop, because at the end this left and right will become equal and left will go beyond right, and at that point all the elements will be searched and will come out of this while loop. And it is the case when the given target element is not at all present in our nums array, then we'll return minus 1. Our code is completed now. Let's try to run it. Yes, all the test cases are given, test cases are passed. Now let's try to submit it. Yes, it is working absolutely fine. Hope you understood the concept of this problem, and I'm going to see you in the next video. Till then, bye bye.